Hey guys, our 8.4 notes will be over vector, and this is the day one of it. Well, a lot of quantities are determined by their magnitudes, such as the length, the mass, the area, the temperature, energy are a few. Only one number is needed to describe these quantities, and this is known as a scalar quantity. To describe displacement of an object, two numbers are required, a magnitude and a direction. Velocity, acceleration, and force are all directed quantities and can be represented by a vector. What exactly is a vector? A vector is a direction and magnitude. Well, it has a direction, it has a magnitude. And when we talk about magnitude, we're talking about the size, or I should say the length of that vector. The scalar quantity has no direction. Example, the volume or the speed. So when I'm talking about I'm going 50 miles per hour. It doesn't tell you which way I'm going. However, a vector will tell you the exact direction, and not only the direction but also the distance, or I should say the magnitude. A vector can be thought of as a directed line segment. So if I want to draw a vector, I would draw something like this. I need an arrow, of course. So a vector would be something like this, where it has a place where it starts. We usually call it the initial point, and the place where it ends is the terminal point. Some others we think of it as the tail and the head. So the initial point is actually your tail, and the head will be your terminal point. Equal vectors. Equal vectors are vectors with the same length and direction. So if I'm looking for equal vectors, let's say this is the first. Let's say this is the first vector. I will draw it like this. In order for me to draw another vector, it must be parallel to the first one with the same magnitude, meaning same length. These would be equal vectors. Now, if I draw one on the other hand, I'm going to draw it as a dotted one. This one, on the other hand, is not equal to this. A vector that is equal to this dotted line will be another one here. Parallel with the same magnitude. Parallel with the same magnitude. The one I kind of drew in between, this is not equal. So these three vectors are somewhat equal, and these three are also equal. Now, a vector v, usually we write it as follows: v equals ab. This only means that it's a times I plus b times j. Now, I and j is just like the x and the y coordinate. The initial point in this expression will be the origin, and the terminal point is at a comma b. This is a point. So a is the horizontal component of v, and b is the vertical component of v. So let's go ahead and try by drawing v, whose description is -3, 4. So the first thing I would do is, of course, draw my x and y coordinates, knowing that I have my x coordinates here, my y coordinate here. Now, to be able to draw that vector, I would first start by -3 is on my x, -1, -2, -3, and 4 is on my y, 1, 2, 3, and 4. So the point that I get at the end is actually my terminal point. So to graph this vector, I'm going to make it a dotted line. It will be from the origin all the way till this red line. And that's the vector v. Let me go ahead and label a few things. This one will be -3, and this one will be 4. And of course, that's what makes the vector. All right. One way of finding the magnitude of this vector, knowing that -3 is my x, I can call this one -3, and this one, this distance is 4, this distance is 3. So if I sit in this specific triangle, meaning this highlighted triangle, I have a right triangle there. So with the right triangle, I can easily use my SOHCAHTOA. So using the SOHCAHTOA, I would say, knowing that this is 90 degrees, Let's call this angle theta. Who cares? Why not? So I will say tangent of that angle theta is equal to the opposite 4 over 3, of course negative because it was negative there. Now, the fact that we're in this quadrant, I don't really need to know. Keep in mind, I'm talking about magnitude, so we're looking at distance. So this really doesn't matter. I can call it 4 over 3. So I will find the theta as the tangent inverse of that 4 over 3. And here you will end up with theta is approximately equal to 53.130. Note that I cancel this because I'm looking for the reference angle. If I didn't cancel the negative, I'll be looking for something else. I'll be looking for an angle here because that's the belly, and note that it's every 180. So I pick this angle. All right, let's go ahead and look at the magnitude of V. Well, to find the magnitude of V, I will start by saying have it like this. Note that it's not absolute value, but it's magnitude, and is equal to the square root of -3 squared plus 4 squared. And -3 squared plus 4 squared will give you exactly 5. And that's your magnitude. Now, beside the magnitude, we also need to know the direction. Well, the direction is given by this angle. The angle from 0. So to find that angle, I will do 180 minus the reference angle that I got earlier, which is 53.130. And this will give me approximately 126.870 degrees. This is your direction, and this is your magnitude. All right, let's keep going. If a vector V is now represented in a plane with initial point P as x1, y1 and terminal point Q at x2, y2, then the component form is V, x2 minus x1, y2 minus y1. Let's go ahead and practice that on this first problem. Find the component form of the vector U with initial point at -2, -5. So -2 is it -2, +5. So I have a point here at -2, +5, and terminal point at 3, 7. Why don't we use that formula I just gave you? I will say U, this is a vector U, is equal to, inside my fancy bracket or my bracket, I will call it this way, I will have 3 minus -2 for the first component, and the second one I will have 7 minus 5. And if I solve this, I will end up with 5, 2. 5, 2, not a problem. That means I start at 5 units on the right and 2. If the vector V is now 3, 7, is sketched with the initial point 2, 4, what is the terminal point? Now, at this time, I start with 3, 7. And what I'm trying to know is, it started at 2, 4. So remember, it's x minus x1. So I will say x2 minus x1, which is where I started. And I started here at 2, 4, so minus 2. And I will also have y2 minus y1, which is 4. Now that I have y2 minus y1, if I solve this, I end up with this is equal to 3. For me to get 3 here, x2 got to be 5. Now I'm looking for a point, so it's 5, comma. y2 minus 4 is equal to 7, so y2 must be 11. Why don't we go ahead and graph this? The first one on this one would have been starting, the initial point is at -2, 5, meaning this point. And the terminal point is at 3, 7, 3, 7, meaning this point. So this is the first graph I would have had, or first vector. Well, let's go ahead and graph the vector U that we translated to the origin. It's actually 5 units to the right, 2 units up. If you notice, these two vectors we have the same magnitude in same direction. It's just a translation of this vector down here. Now let's deal with v. If I'm talking about v, if the vector v is 3, 7, meaning 3 and 7, which is here, this is v now. It goes from here all the way here. That's the vector v. And we're trying to figure out what is the, if the initial point is at 2, 4, meaning 2, 4, right here, where will it end instead? Note that it traveled 3 more here. So based on what we got, it will go back to 5, 11. Here's the sketch the representation of vector w2, 3 with initial point 0, 0, negative 2, negative 1, and 1, 4. So I'm going to erase this one and sketch the new one there. Let's start with the vector w, which we will sketch at, I'm going to use purple on this, 2, 3. 2, 3. Here's the vector w. That's initial point at 2, 3. Now let's do one with the vector w, initial point at 0, 0. That's what I meant. So this is the 0, 0, the purple one. The blue one will be at negative 2, negative 1. In order for me to get this one at negative 2, negative 1, I notice that they travel in 3, or run 2, rise 3. Run 2, rise 3. I'm showing you shortcuts. Now I'm at negative 2, negative 1, meaning negative 2, negative 1 right here. I will still run 2 and rise 3 to give me this new vector. Let's go ahead and do the last one at 1, 4, meaning 1, 4. Do the same concept. Run 2, rise 3, and I'll be able to graph another vector. All these vectors are identical. They all W. All of them will be the same W. It's just starting at a different location. All right, let's find 2u. To find 2 times u, well, all you have to know is, let's give ourselves a u. Let's say u is, let's give it 5, 2. As we stated before, u is equal to 5, 2. I'm using the same u as up here. 2u will therefore be equal to, you multiply everything by 2 and you just get 10, 4. Now, the magnitude of 2u, on the other hand, remember, it's not absolute value, it's magnitude, is equal to the square root of 10 squared plus 4 squared, which is equal to the square root of 116. And if you simplify it, you get 2 root 29. Let's a be equal to 1, negative 3. Find a plus u. To find a plus u, I will say, well, a. Let me change this pen. That will be a plus u will be equal to, if I go ahead and figure out what a plus u is, knowing that u is 5, 2, I will say a plus u is equal to adding the 5 and the 1. So I'm adding these two values to get 6. And if I also add my y values, I get negative 1. In other words, a plus u is just adding the x values, adding the y values, or adding the first values together to get the first value of the sum, and the second values together to get the second value of the sum. The magnitude of a plus u will be equal to the square root of 6 squared plus negative 1 squared. Make sure you use parentheses, and that will give you the square root of 37. Let's go ahead and move on. Sum of two vectors. If two vectors are placed head to tail, the sum is the net displacement from the tail of the first vector to the head of the second. What do we mean by that? Let's say I'm adding two vectors, one of them being this, and the second one being this. Note that the tail and the head are, the head of one is with the tail of the other. So if I want to combine these two, my answer is just the net, meaning the distance from the tail. the distance from the tail to the head. So if this is my X, this is my Y, this one will be my X plus Y. Now, it will be a different story if now the distance, if they not link head to tail as follow. So let's say, for example, let's start with my X and Y coordinates. I have my Y coordinates here, my X coordinates here. Let's say I have a vector. I will give myself the first vector. Let's say 1, 2, 3, 3, 4. Why not? 4 and -1. Here's my first one. The second vector I would say is 1, 2, 3. Why not? And -2, meaning here. To find the addition of these two vectors, note that the heads are not facing opposite direction and the tails are touching each other. To find the sum of these two, I will say A plus U. Let's give myself some values here. For this one, I know that let's call this one A, and let's call this one B. Why not? Or U. A here, I'm giving myself coordinates of 1, 2, 3, 4, -1. And for U, I'm giving myself, this is -3, -2, -3, and -2. If you want to find A plus U, you will say A plus U is equal to, we add the X value, or the first value, I will get 1. And if you add the second value, you get -3. Well, it's at 1, -3, meaning somewhere here. In other words, it's this distance. What you actually did here is, if you build a parallelogram from this, translate this one here, you should get this red line. I'm translating the vector U to this second dotted line here. I messed up here. Well, if you translate it, you will end up with this vector here will come here, and this vector here will come here. So you can add it by looking at it this way. All right, note that this one is also U, and this is also A. And if you translate just the U, you end up with now a vector facing this way, a vector facing this way, and it's easier to connect with the blue line. All right, vector subtraction. The opposite of V is, of course, -V. Same magnitude and just opposite direction. In other words, the opposite of this one is this one. And if you add them up, you get nothing. That's V, and that's -V, and this is V. Those are opposite. So let's go ahead and move on to the next one. Given A is equal to 5, B is equal to 9, and the angle between them placed tail to tail is 53 degrees, find A plus B. Now, here we have both vectors facing two different directions, tail to tail as they said. And we know that the angle in between them is 53. Now, the angle between them when placed tail to tail is 53 degrees. So this whole angle is 53 degrees. Based on what I showed y'all earlier, to find the sum of these two, look what I would do. Pay close attention to this. I can slide this vector up to line it to this, and now that they head and tail touching, I'm capable of joining these two to make the sum. Look that I was able to slide it. Now, if you decide not to slide it, that's okay. You just have to make it harder. But the easiest thing is to just slide this previous vector. It was here. Oh, I should have drawn it darker color. It was here, and I will call this one is A, and this is B. But as I was able to slide B up there to make it to the point that B and A would be head and tail touching. And now I have the vector, and this vector that you see here is actually the vector A plus B. So if I was given numbers, for A, for example, here I have 5 and B is 9. So I have a triangle like this, where this is 5, this is 9. Now it was 53 here. Well, by cutting it like this, I divide that 53 in 2. Or actually, if this is 53 and I form this parallelogram, this being 53, this also is 53. The sum of these two should give me 180. So this is 127 degrees. So in this triangle, this is also 127 degrees. Knowing that this is 127, I can use my law of cosine. And my law of cosine, we say, let's call this one x. I would therefore say x squared is equal to 5 squared plus 9 squared minus 2 times 5 times 9 cosine of 127 degrees. And if you calculate it, you get x is approximately equal to 12.656. And that's, of course, the magnitude of A plus B. All right, let's look at number 5 now. Number 5, we have A is equal to 3 and has a direction of 143. This time we have a direction. With a direction, we are forced to graph our x and y coordinates. Now, the vector we're talking about is somewhere here. I'll make it a dotted 1 because 143 is from 0. So as of right now, I know that this is 143. And if this is 143, the angle in here would be 37 because I'm taking it away from 180. Now, they say the magnitude of A is 3, so this is 3. Resolve A into its horizontal and vertical component. So our goal is to find lowercase a and lowercase b. Well, it's a right triangle. So I can start by saying cosine of 37 degrees is equal to A over 3. So A is equal to 3 cosine 37 degrees. And if you do 3 cosine 37 degrees, you get negative 2.396. I'll do the same thing for B. This time I will say sine of 27 degrees is equal to B over 3. So B is equal to 3 sine 27. And it will give you approximately 1.805. So the final answer, you will say, we call which vector is that? A. Vector A is equal to, you will put your x coordinate, negative 2.396, comma, the y one, 1.805. All right, horizontal and vertical components of a vector. If theta is the standard position for V, then V is equal to magnitude of V cosine theta I plus magnitude of V sine theta J. In other words, you should know this already because cosine is always your x and sine is your y. So you know that you will multiply the cosine by the magnitude of V to know the first component and the sine by the magnitude of V to get the second component. All right, on number 6, I have A is equal to 5 at 70 degrees and B is equal to 6 at 25 degrees. So to write the coordinates of A, I would say A is equal to, well, it's 5 times, because 5 is the magnitude, cosine of 70 degrees, comma, 5 times the sine of 70 degrees. I can do the same thing for B and say B is equal to, this time it will be 6 times the cosine of 25 degrees and 6 times the sine of 25 degrees. Find the measurement vector R as the sum of two components. So let's start with A. Let's solve for A here. R will be the sum of these two components is equal to A plus B. And if you want that sum is equal to, using your calculator, you will do 5 cosine 70 plus 6 cosine 25. You should get 7.148. And the other one, you will get 7.234. Once again, for the first one, I will do this and add them up to get this value. For the second one, I will add my y values. I can do the same thing now let's go ahead and do the magnitude. To find the magnitude of R, it will be actually simple. It's equal to the square root of this one square, which is 7.148 square, plus 7.234 square. And that will give you approximately, of course, 10.170. Now, if you try to 10.170, yes. Find the magnitude, and to find the direction, all I need to do is the tangent. So I will use the tangent here and say tangent of theta is equal to 7.234 over 7.148, meaning this over this, which is equal to theta will give me approximately 45.343 degrees. I know this is long, but it's very important.